Hi everyone, this is lesson video 6.8, solving by completing the square. Back in 6.3, we learned how to complete the square in case you need to take a look back. And when we did that, completing the square, we ended up with something that looked like this. It was called vertex form, where you could identify the vertex. So we're going to solve, which means we're going to hopefully find two solutions, and we're going to find out where y is equal to 0. If we want to find the zeros of this equation in simplest radical form, you're going to set the equation equal to 0 instead of y, because y will equal 0. And you're going to use inverse operations. So this is a review. Just did this a day ago. So you're going to add 36 to both sides. That leaves you with 2x minus 2 squared equals 36. You're going to divide by 2. Now I have x minus 2 squared equals 18. 36 divided by 2 is 18. And you're going to take a square root, undo the squaring, take a square root, and put a plus or minus. So now I'm left with x minus 2 equals plus or minus. It said simplest radical form. Hopefully you see that this is the square root of 9 square root of 2, otherwise known as 3 square roots of 2. If you're still confused on how to do that, make sure you talk to your teacher about how to simplify a radical. So this is 3 rad 2. Final step, to get x alone, you need to add 2, and you put it in front of the plus or minus. So your answer will look like x equals 2 plus or minus the 3 rad 2. Those are two answers, 2 plus 3 rad 2 and 2 minus 3 rad 2. So you could write that in squirrely brackets as a set. If it says find the zeros to the nearest tenth, you're going to have to use your calculator. So when I had this step, x minus 2, I'm going back to here. X minus 2 equals plus or minus radical 18. What I'm thinking is, since I'm going to hit my calculator to get this decimal answer, I'm not going to bother simplifying the radical. I'm going to enter it as 2 by adding the 2 in front, plus rad 18 and get my decimal, and 2 minus rad 18 to get my decimal. That way I won't make a mistake simplifying the radical, and I can just go to my calculator. Okay, so here's my calculator. I'm going to hit 2 plus the square root of 18. And then just to be on the safe side to type the same thing, I'm going to highlight it and hit enter and backspace. Oh, come on, calculator. Delete that plus and change it to a minus, and then hit enter. So my two decimals to the nearest tenth will be 6.2. 0.2. There was a 4 right here, so 6.2. The 4 doesn't make that go up. And negative 2.2. Negative 0.2 to the nearest tenth. If I had typed in the 2 plus or minus 3 rad 2, I would have gotten the same two decimals that I got that way. Okay, so here's the deal. When you look at this equation, it's in standard form. The equation we just solved was in vertex form. So when it's in standard form, the first thing I would try to do is solve it by factoring. So we're going to find the zeros. X squared minus 6x minus 16 equals 0. Hoping that it factors relatively quickly if you're getting good at factoring. Two numbers that multiply to be 16. That'll give me a 6 are 8 and 2. Signs have to be different. So again, factoring, if you're not that quick at it, you could have graphed it, looked at the roots, turned your roots into factors. Once you get them, you set them equal to 0. X minus 8 equals 0. Add 8. X equals 8. X plus 2 equals 0. Subtract 2. X equals negative 2. So, same equation. We're going to find the zeros of this one by completing the square, which means we're going to get it back into the form of exercise 1. So when you have your x squared minus 6x minus 16, you're setting it equal to 0, just like we started the last question. You're going to separate your 16. So if you remember, we used to just put a blank and have the 16 sitting here. So we're going to do the same thing and not forget to add our number in both places. So it's kind of like you're going to have another number right there in a second. Anyways, all right, let's take our 6 and try to split it into 2 equal pieces. So we are going to start to factor this thing into x and x. Half of 6 is 3. I'm using a minus because it's a minus 6. And then if I look at that number, it's actually a 9. Or I took negative 6, I took half of it, I squared it. We're completing the square, remember. Negative 3 squared is a 9. When you add the 9 in on this side of the equation, you got to take the 9 off. So now I have x minus 3 squared, oh goodness, x minus 3 squared minus 25, because this would be a minus 25 right there, equals 0. And I've only completed the square. I have not found the zeros. I have not done the solving yet. I still need to solve that. So I'm going to add 25 over to the other side. I'm going to have x minus 3 squared equals 25. I'm going to take a square root, put a plus or minus, and I'm going to add 3 to get x alone. So x minus 3 equals plus or minus 5. That's the square root of 25. Add the 3 in front, and I have x equals 3 plus or minus 5. My gosh, I have run out of room. What am I going to do? Okay, I'm going to take it way over here. Sorry about the mess. So I got 2 problems I got to do to get these x's. I got to do 3 plus 5 and 3 minus 5. My answers are 8 and negative 2. Look at that. 8 and negative 2. Same darn thing. But this had a lot more steps this time. Sometimes factoring is easier. Sometimes finding the zeros by completing the square and using inverse operations is easier. By the way, I didn't just complete the square. I then used inverses to do that math. Okay, let's take a look at a quadratic that looks like this. It says find the zeros using the method of completing the square. And then what kind of numbers are these solutions? So we got x squared plus 6x plus 2 equals 0. I'm going to make my space blank plus the 2 equals 0. If you didn't notice this already, I could have moved that number over to the other side. So I probably could do that, but I'm just going to, for consistency, this is the way we've been doing it. So you're going to split that 6 in half. This time it's a plus 3 plus 3. That makes a 9, so I need a 9 right here. So there's my x plus 3 squared. That's this part. Since I added in a 9, I need to take off a 9. So this number gives me a negative 7. Keep your equals because you still have an equation to solve here. So I'm done completing the square. Now I'm going to solve. So I'm using inverse operations. Add 7. So it's x plus 3 squared equals 7. Taking a square root, x plus 3 equals plus or minus the square root of 7. Okay, so here it asks what kind of, I'm sorry, my little cough is driving me crazy. What kind of numbers are these solutions? Right now I can tell that 7 doesn't have any other factors besides 7 and 1. It's not going to be able to be simplified. So my numbers are going to be irrational. I can't take the square root of 7. It's going to give me an ugly decimal. But I'm not totally done. It's going to be negative 3 plus or minus the square root of 7. Since this is not a nice number, I can't add and subtract like I did up here. Remember, I was able to add and subtract the 5 because that was a whole number? Down here, I can't do that because the square root of 7 is not nice. So I can just write it as negative 3 plus the square root of 7, negative 3 minus the square root of 7. And those, again, are irrational numbers. Why would you not use factoring? Why would we not use factoring to solve this? Well, if you look at it, it's because it's not going to factor. It's not factorable. Not every equation is factorable, so this is a really nice method to know how to do. In other words, 2 numbers that multiply to be 2, the only choices are 2 and 1. There's no way that I'm going to have a 6x magically appear out of that mess. There's just no way. Check out your box method, do whatever you got to do. You could actually graph it and find out you're not going to find any nice roots that you can turn into nice factors. It's just not happening. So you need an alternate method. Turn the page. All right, let's analyze this quadratic written in standard form. If you notice, this one has a 2 in front. That makes everything more difficult. So to change this into vertex form, I'm going to start with f of x equals, taking out the 2 from the first two pieces. So I'm taking the 2 out of these two pieces, x squared minus 2x. In other words, I divided those first two pieces by 2, and I still have my minus 16 right here. Remember, just ignore the 16 for a second. So now I'm going to complete the square on the stuff that's inside the parentheses. I'm trying to get vertex form. Y equals ax minus h squared plus k. That's the form of vertex form. So I got to complete the square here. 2 x squared minus 2x plus blank minus 16. To fill in that blank, I start looking at these factors, x and x. Split that negative 2 in half, minus 1 minus 1. That's going to be x minus 1 squared. Okay, but I still have the 2 in front of it. And when I look at this number I created, that was a 1. So I put a 1 right there. Negative 1 times negative 1 is a positive 1. That's actually doubled, so that's actually a 2 that I just put in, so I need to take off a 2. That's a negative 18. Sneaky, sneaky, got to be careful. So my function is 2 x minus 1 squared minus 18. That's vertex form. The turning point then, the TP, looking at that equation, is 1 to the right and 18 down, negative 18. Okay, so using my answer, now find the zeros. So from vertex form, 2 x minus 1 squared minus 18, find where it's equal to 0. So I'm replacing my function, my y, with 0. All right, I'm going to add 18 over to the other side. I'm doing inverse operations is all I'm doing. I have 2 x minus 1 squared equals 18. Working your way into the square, you got to divide away the 2. X minus 1 squared equals 9. And now I got to get rid of the squaring with a square root. And sing it, everyone. When you take a square root, you put a plus or minus. That's my best singing voice when I have a cold. Square root of 9 is 3. So I have x minus 1, no more square, equals plus or minus 3. The square root of 9 is 3. Add 1 in front of the plus or minus. I got 2 answers. 1 plus 3, 1 minus 3. 4, I'm just doing the math, and negative 2. So that was kind of nice. Oh, that's a negative 2. Can you see that? 4 and negative 2. Determine the function's y-intercept. All right, this is just to throw a curveball at you. A y-intercept on the y-axis, any of these points over there on that graph, would be 0, comma, some y number. So the x value is 0. So I want f of 0 instead of f of x. So my function, back up to the original, is 2 something squared. Why is my marker doing that? Hold on a second. I don't know why. All right, so what I'm doing is I'm looking back up at this function, 2 something squared minus 4 times something minus 16, and that something is a 0. Instead of f of x, I got a function of 0 now. So 0 squared is 0. 2 times 0 minus 4 times 0 is 0. Okay, 2 times 0 is also 0. I'm just doing the math. I could have just calculated this. I could have put this whole thing in my calculator and gotten a number. I would get negative 16. So 0, negative 16 is the y-intercept. It's way down here. I also found these things in the previous question, so I can label all these quantities that I just found. Negative 2, that would be about there-ish. 4, just estimating these values, obviously. So negative 2 and 4 were my zeros, and I can sketch this randomly skinny. I'm not really sure where it turns. Did I find that? Wait a minute, I bet I did. Where does it turn? Go back up to the original. Oh yeah, I found my turning point. 1, negative 18. 1, negative 18. Right there, 1, negative 18. So everything starts to come together and you're able to make the parabola. All right, last example here, exercise 5. The quadratic function pictured has a leading coefficient equal to 1. So that makes me think quadratic function, leading coefficient is a 1. Write an equation or the equation in vertex form. Y equals vertex form. There's a 1 here, remember. X has something in with it squared. So let's take a look at the vertex. Negative 1, 1, 2, 3, negative 4. If the vertex is at negative 1, negative 4, this is a plus 1, this is a minus 4. It went 1 to the left, so that's plus 1, down 4. There's my function in vertex form. Write the equation in factored form. That's interesting. So it's x plus 1 minus 4. That's not factored form. Factored form just has factors like this. I got this extra minus 4. I'm going to multiply this out. If you needed to use boxes, you could. X and a 1, x and a 1. It's going to be, real quick, x squared plus 2x plus 1. X squared, x 1. And then minus 4. Combine these like terms. Final answer. I'm going to get rid of my little boxes that are in my way. Final answer, y equals x squared plus 2x minus 3. Prove algebraically that these are equivalent functions. Well, if I take a look at this, is it the same as this? I think I just did prove that algebraically because they are exactly the same thing. Another thing I could do is look at x squared plus 2x minus 3 and complete the square on it. So let's complete the square on this. Let's see. I'm going to create my space for my perfect square. Let's create some space there and try to factor this. X and x. I'm completing the square. Split the number in the middle in half. Plus 1 plus 1. That's a 1. Add 1 right there. I'm completing the square. I just added in a 1, take away a 1. Now I have x plus 1 squared minus 4. And that is what I had there. So you can move between the different forms by doing lots of awesome algebra. But I just noticed that this question up here said write this in factored form. And guess what? This is not factored form that I ended up with. So I really should have looked at this as y equals x and x. 3 and 1 are the factors of 3. Or, looking at these zeros, that's negative 3, so that's a plus 3. That's a positive 1, so that's a minus 1. And then I could have multiplied this out and proved that it was the same thing as that. Eventually, you're just going to see that everything that's in a box right now could multiply out and give you the other thing or complete the square.